I just want to kind of go over two of these really fast. So it says the square, number 2 and 1 we already did. So 3, it says the square of a number is 16. Do you know the number that you would use to square it? And the answer actually technically is no. And here's why. Because we're going to get multiple outputs. And with these, you should exactly one output for every input. You should get one y for every x. And if you're getting multiple, then that's not right. So the reason why this is a no, oops, is because of this, right? If we have our diagram here, okay, and what we're trying to find is that if you have a square, or you know that x squared, sorry, hold on. If you know that x squared equals 16, right, what would the answer have to be? And so in reality, our rule is this, okay? In the reality, this is our rule, is this. The square root of 16 would be what? Now, the issue is that if you have 16, sorry, it's actually not supposed to be 16, it's supposed to be x. What would the answer be? And the problem is that if you were to plug in 16 in the square root, your answer technically could be -4 or 4, okay? And the problem with that, y'all, is that that's two outputs. You technically could square a -4 and still get the same answer, or square a 4 and get the same exact answer. So you have to be very, very careful with this one. The answer is a no. And the only other one that has a no that I will do is 5. And it says a rectangle has an area of 16 centimeters squared. Do you know its length? Well, the problem with this is that a rectangle has an area of 16 centimeters squared. Do you know the length? And there's so many different answers we could use for the length of a rectangle to get 16. And that's why this one's no, right? I mean, you could do, there's just so many options. You could do 1 and 16, right? There's one option. Another option, if we had another answer here, because remember, area is length times width, is you could do 2, technically that'd be this, 2 and 8. And that would give us 16. There's another option, okay? So there, because there's automatically already 2 there, this is also a no answer, okay? So the next thing we're going to do is 2.3 using the functional language. This is the backside, and this is pretty vital for your success and understanding of this. So it says, for the ones you said yes to on the backside, I want you to write a statement like, the height of a rubber ball bounces to depends on the height it was dropped from, or bounce height is a function of drop height. For all of the ones you said no to, write a statement like, the day of the week does not determine the temperature of that day, or the temperature that day is not a function of the day of the week. So for instance, let's go down here. The first one says a person is 5.5 feet tall. Do you know their height in inches? And we can say the height in inches is determined by the number of feet tall the person is, okay? Number 2, it says the number is 5. Do you know it's square? And we can say the square of a number is going to be 25, right? Or the base of a number that's 5 will give you the square of 25. Something along those lines, y'all. So don't overthink this part, but make sure you understand how to write out exactly what the function is doing and how to get from point A to point B, okay? In reality, we're just changing our machine and writing it in words now. All right. So if you have any questions, please let me know. But go ahead. I'll give you about 10 minutes for this one as well. When you are done with this activity, you will turn it in. Okay. Now, 2.4, you can actually do when you're done with the top. It just says which input output rules would describe the same function, if any, be per their example. So in reality, we're just kind of going through this and seeing which ones have a similar idea. Of each other. Okay. When you're done with this, go ahead and turn it in, and you'll do the next activity if you have time. Cool. Have a good day. I'll see you in the next video.